All right, just continuing on the second video. I got scared there for a minute. I wasn't sure it was still filming, so that's why I stopped it. Here it is, radian measure. So we have a second way of measuring angles. It doesn't have to always be in degrees, even though that's the preferred way, definitely, to measure angles. So here it is. I'm going to draw a circle. So we can use radian measure. Again, you can measure an angle, doesn't have to be in standard position, just so we could have a degree measure. But a radian measure definitely starts on a circle. We're going to move this one as well and put it on the XY plane, but here it is. Now, any circle has a center, right, and a certain radius. So what we're saying is if you have an angle that has an opening that cuts off we call this an arc length. So if the arc length that is being cut off by this angle is got the same measure as your radius, then we say that that angle measures 1 radian. So if the arc length of the arc cut off by the angle, I'm going to call this by the central angle. So what's a central angle? A central angle has the vertex in the center of the circle. And again, if you were wondering why you had to take that geometry before you got to trig, and then before you got to pre-calc, well, finally it seems like it's paying off a little bit. Okay, so if the arc length of the arc cut off by the central angle, theta, let's say, it measures the same as the radius, then we say that theta is equal to 1 radian. That's a radian measure. Okay, so we usually call S the arc length. So let me draw another circle. And here is an angle, theta, and it measures I don't care what. This is the radius though, and what this length is might not be 1, it might be 2 radiuses long, it might be 3 radiuses long, as a matter of fact. About 1, 2 1/4, I'd say, if I were to estimate. Okay, but we call the arc length always by S. So we're going to say that theta is equal to S over R many radians. Now, of course, on a side, if S is equal to R, right, so if the arc length is as long as the radius, then sure enough, theta is equal to 1 radian. Right? But let's say it's twice as long, then it's 2 radians, right? Let's say it's 4 times as long as the radius, well, then it's going to measure 4 radians, right? So that's how we measure this. Okay, now of course, the big question is, how do we convert between radians and degree measure? It's pretty simple. All I have to do is think about a circle and an angle that's going to measure how much? Full degrees, right? So it's a full angle. Now this angle, again, call it theta here, is 360 degrees, yes? Now, what would be its measure in radians? Well, its measure in radians is whatever the arc length is. Sorry about all these pens. This is the arc length that it's being cut off if you go full circle, yes? The whole circle, right? That's the arc length. The radius is r, yes? So what's going to be this s, the arc length? Well, the arc length is the whole length of the circle. So does anyone know what's the circumference of the circle? Well, the formula is 2 pi r. So there you have it, 2 pi r, which is the length of the whole arc, right? The whole circle, right? That's what we're cutting off. That's going to equal to 2 pi. So we have our connection that 300 degrees is the same thing as 2 pi radians. Now the thing is, with radians, it's kind of like a unitless measure. Definitely we don't have a symbol for it. That's the problem, first of all. Second of all, radians is a lot to write, so we kind of don't write it at all. So we just say 2 pi and we know it's radians. So if you don't put, that's why it's so important to actually put the degree symbol on a degree measured angle, because if you don't, I'm going to think it's 360 radians, right? It doesn't have a degree to it. Okay. Now, of course, this can be simplified. I can divide both sides of this by 2 and simplify that 180 degrees is the same thing as pi. Again, what kind of pi? Radians. But we don't have to write it. We know if we don't write a symbol, it means radians. Okay, so that's the conversion. In other words, same as 1 foot is 12 inches, right? That's the conversion between degrees and radians. So what we're going to do is just simply convert a little bit. So let's say I'm going to start with a 300 degrees angle, and I want to put it into radians. So what do I simply have to do? Remember, pi is the same thing as 180 degrees. So all I have to do, pi over 180, since they are equal to each other, this thing is equal to 1, yes? So what I want to do is I want to get rid of the degrees and bring in the radians. So the degrees cancel out. 300 over 180, this reduces to, I can reduce it by 6t, and that's going to be a 3 and a 5, so that's 5 pi over 3. And again, radians, because I don't write anything. Okay. What about negative 150 degrees? Same thing, multiply by pi over 180. The degrees are gone. You can reduce 180 and 150 by 30. And it's still a negative degree measure, and that's negative 5 pi over 6 radians. Right? Let's try one more. I don't know. Maybe 600, something. Oh, no, we had 300, so fine. How about 230 degrees? Times pi over 180. Again, not much is reducing, just the 10, right? So that's 23 pi over 18. There you go, done. Okay, let's go the other way. Pi over 6. Definitely a radian measure. Why? I didn't put degrees to it, right? How do I transform it into degrees? I'm going to want to bring in the degrees and get rid of the pi's. So 180 divided by pi, and that's nothing but 30 degrees. So we're going to have to know this conversion between degrees and radians pretty fast. And the more we'll practice, the easier for you. And maybe you already know pi over 6 is 30 degrees, done. It's just, these are one of our famous angles. We're going to be able to convert and just look at it and know the conversion super fast, just because it's one part of the angles that we're going to be dealing with quite a bit. Okay, so let's say negative 7 pi over 2. What kind of a degree measure does this have? Again, I want to bring in the degrees. So again, do not forget to put the degree symbol. Okay. So the pi goes away. These reduce by 2. So 90 times 7 is 630 many degrees, right? Negative. Okay. What about 3? Of course, I know what you're wondering. Where is the pi? No, 3 is 3. Why? Where's the pi? Well, you don't have to have a pi always, too. It's nice if it does, because then it's an exact value we're going to get. But pi, remember, is a number, right? In fact, what is, and again, this is not degrees either. Why is it not 3 degrees? Because I didn't put the degree symbol. This is really the number 3. If you were to take your calculator and put pi over 6 in, what's really pi? Pi is 3.14 over 6. That's really another way, and I don't have a calculator. I just do with my calculator. Oh, well, whatever. I'm just going to say that's a little bit less, a little bit more than a half. So that's about 0.56-ish, I'm going to say, is my estimate. So there you go. I basically measured the what? 0.56 radians, right? By the way, if I don't write anything, is the same thing as 30 degrees. Okay. So how do I measure or change 3 into degrees? Well, all I have to do is multiply by 180 degrees and get rid of the pi radians. So put this in your calculator, 3 times 180 divided by the way, there's a pi button on it, and you're going to come up with about 114.6 degrees. Okay. So again, where does a 3 radian angle fit in? Well, obviously now I know it's in second quadrant, right? But think about the circle, yes? And where an angle of 3 radians, where would an angle of 3 radians, I wish I had a better circle. But all I have to do is think about an angle in standard position, and this is how long my radius is, right? And so a 3 radian means what? From here, I need an arc length that's 3 times as long as the radius. So that's 1 radius about, that's 2 radius about, and that's 3 radius about. Again, my circle should have been a little bit better scaled. But as you see, a 3 radian angle fits about in second quadrant. By the way, just to be clear, 2 pi radians, that's really how much? Pi is 3.14 times 2, that's 6.28, right? That's just another way of writing 6.28, blah, 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 whatever, right? So around the circle, right, one time around the circle, 360 degrees, that's about how many radians? It's about 6.28 radians, right? Because that's what 2 pi is. Okay, all right. So a few more things, just a couple more formulas, arc length and area of a circle. You've done also these in trig, so I just wanted to remind you of those 2 formulas. So going back to our circle, really easy. And going back to a formula I already wrote, so if you have an angle theta, right? This is the radius, and this is the arc length. All right. Then what did I say? I said that theta is equal to S over R, right? And if S is the same as R, then we're measuring 1 radians. Now, of course, from here, I can easily come up with this formula, that the arc length cut off by an angle of theta, but it's very important, radians, because remember that was the radian measure of theta, right? Just take the arc length and divide it by R. So theta must be an angle in radians for you to be able to use this formula, right? Okay, so there's the formula to find the arc length. And the same way, easily, not only can we find this arc length that we're cutting off in this circle, but we can find the whole area of this sector. This is called a sector. That slice of pizza is called a sector of a circle, okay? And this formula is maybe a little bit more complicated and not so easy to memorize. I don't have it memorized. Well, I do know it because I've just used it plenty of times lately teaching pre-calculus, but it's not something I'd be carrying with me all my life. But I could figure it out in about 2 minutes time. And so I'm going to show you what I would do if I wouldn't remember this formula, just in case you ever forget it. So this is as simple as that. This piece of the pie is just a proportion. It's a proportion of the whole circle. So what I'm saying is that what? This area is to the whole circle, right? Which is what? What's the area of a circle? It's pi r squared, right? So this area is to the whole area of the whole circle in the same relation as the angle theta is to the angle all around the circle. And again, I know you might be tempted to say 360 degrees. That's what a full angle measures. But remember, we want the radian measure of that. And the radian measure of that is simply 2 pi. Okay, so this and this is the measure of the full angle in radians. Okay, so it's in the same proportion. So again, what did I want? I wanted a formula for A, so all I have to do is cross multiply. So A times 2 pi is equal to theta times pi r squared. And then A I'm going to divide by 2 pi. And as you see, the pi's are going away. So A is equal to theta times r squared over 2. Now we have a much prettier formula or version of it, that the area of a sector is equal to 1/2 r squared theta. R squared theta. Where again, theta must be in radians. Is an angle in radians and not otherwise. Okay, so that's the formula. It's kind of like, I remember, yeah, again, you can remember the pi r squared, so there's an r squared in here as well, but of course it's tied into, it's a sector that's being cut off by a certain angle. So it depends on that angle's measure, right? So that's why it has to have the angle theta in the formula, right? Okay. So 2 quick applications and we're off. So find the length of the arc, which in other words, what's the length of the arc? That would be S, yes. And the area of a sector, we'll call it A, in a circle with the radius is 6 inches, cut off by an angle theta that's pi over 3. So is this degrees or is this radians? Of course, the pi gives it away, but it's really not. I can put pi degrees, and that would mean 3.14 degrees. What's 3.14 degrees? Well, a tiny, tiny angle like that. That's about 3.4 degrees. So what gives it away is that it doesn't have a degree symbol to it. So we have the 2 formulas. What are the 2 formulas? S is equal to r theta. So all I have to do is take the 6 inches and multiply by pi over 3. So that's 2 pi many inches, or about how much? 6.28 many inches, right? And what's the area? Is 1/2 r squared theta, right? The formula we just derived. So 1/2 times 6 squared times the angle is pi over 3. So that's 36 divided by 2 is 18. 18 divided by 3 is 6 pi many square inches, right? It's the inches here are being squared. It's an area. Now, what is this exactly? Put in your calculator. That's about 18.84 square inches. There you go. All right. And we'll do this one more time. Find the length of the arc S and the area of the sector if R is equal to 10 centimeters and theta is 50 degrees. So be very careful with what? Is this a radian measure? No. So because it's not, we must convert, first of all, to radians. Okay, so let's do that first. So theta is, how do I convert from degrees to radians? Well, I want to get rid of the degrees, yes, and bring in the radians. So that's basically 5 pi over 18. We'll just leave it at that. We need more formulas. In other words, we need to do something else with it. I can put the whole thing in the calculator at the end. So I wanted S, which is r theta. R is 10. Theta is 5 pi over 18. So this is what I'm saying. You can put this in your calculator. 50 times pi divided by 18 is, I don't know, I didn't put in my calculator. But definitely you can also reduce and leave the answer in exact form. You don't have to put the decimal in, but I just want to give you an idea. About 75, it's about, I don't know, 7 point something many inches. And A now is 1/2 r squared theta. So same thing. We now have the theta nicely in radians, just as we wanted. So multiply all this in 100, so that's 50 times 5 is 250. And I can even reduce this, 125 pi over 9. But be careful, these are square, oh, not inches, but centimeters. Whoops. So centimeters squared. So the computations are easy. The formulas are easy. They definitely make quite a bit of sense. I wouldn't recommend you memorizing them. Just think about what happens and you can easily come up with these formulas yourself. Okay, this is it, 5.1.